welcome back to my channel EduVibe. In today's lesson, we're moving to the next topic of the Unit C, Grade 11 Chemistry, which is the modified ARRHENIUS theory. So we're doing the modified one, the original we can't do, and this was the main topic of this unit, and you have to know about the how the ARRHENIUS theory works in different parts, in different like compounds and the molecular compounds. So what is the modified ARRHENIUS theory? So the modified ARRHENIUS theory better explains the acidity and the basic properties of the substance that original theory could not explain. Why we're not doing the original theory? Because that original theory didn't explain the basic things about the acidity and basic properties of the substances. That's why we're doing after that they made the modified ARRHENIUS theory, which we're doing now. So this theory is still limited, but in that it can only describe the acid-basic chemistry in the aqueous solution, and it does not always allow you to predict whether the substance will be an acid or a base. So in this theory, there is a limited information in that too, but this describes the acid-based chemistry when we have in the aqueous solutions. So that's why we're doing that theory, and this theory is very important. We're doing the lots of things in this, so be prepared for that. So, according to the modified ARRHENIUS theory, acids are substances that react with water to produce the hydronium ions. So, with the modified ARRHENIUS theory, we already discussed this topic in the previous lesson, but we're doing the introduction to the acids and bases. That in ARRHENIUS theory, when any acid react with the water, this will produce the hydronium ion. So, hydronium ion is like this: H3O positive. This is the hydronium ion. For example, if we have any like acid, if I take HBr, which is from a top cells, is the strong acid, plus I react with this water, I will get a hydronium ions. Plus, so H and hydronium ions goes with this, we'll have to Br. So Br minus, like this. So that's the way to write the modified ARRHENIUS theory, and we discuss that thing later on slides. But this is very important to know. And same with the bases. So according to this theory, bases are substances that deassociate or react with water to produce a hydroxide ions. Now, if we take like NH3 aqueous plus water in liquid. Now NH3 is a weak base, so we have to write this equilibrium sign. You know that. So we discussed that too, but this sign is used when we have a strong weak base or a weak acid. We use that sign. This is equilibrium sign. After that, this will deassociate and this will become NH4 positive, and we get OH minus, which is the hydroxide ions. You can see over there too. So this will produce, bases can be like deassociates or produce the hydroxide ions, which is OH negative. So that's how it works. We'll learn more about this in grade 12. So be prepared for that. So then we have a neutralization reaction. So neutralization is defined as a reaction between the hydronium ion and the hydroxide ion to produce the water. We have hydronium ions, we have the hydroxide ions. This will neutralization reaction uses to produce the water, and we get the water like 2H2O. This is two waters. So this is the main thing for the neutralization reaction. When the hydronium ion hydroxide ions can be react with each other, they produce the water in little bit large amount. Then how can we write the chemical equations for the monomer? We have a different things. There are 6 ways to write this. There are different ways because we have a different kinds of molecules. We have a compounds, we have acids, we have bases, we have metals too, metals and non-metals. So that all thing can be done from there. Firstly, we have the ionic hydroxide. If we have any ionic hydroxide, what can we do? So if we get any ionic hydroxide, which is basically the basis, so write a deassociation equation with the hydroxide ion as a product. You should be write the whole your deassociation like we write over there. Over there we get NH3 and we made this modified NH theory equation. Because of this is the like of a weak base. We write it like that. But if we get ionic hydroxide, this is basically a strong base, which has the like OH on the end. So this is the strong base, and we have to write the deassociation equation with the hydroxide ion as a product. So how can we write this example for this? So LiOH OH, which is in solid, they given us. So this is in solid, and you can write plus water, or you can write put the arrow and write this like this because this is a deassociation, and we get Li positive aqueous. This has a positive sign, one positive, plus OH negative aqueous. So this is the reaction for the if we have ionic hydroxide. If we have MgOH2, this is all goes with that thing. You have to use this always. Then if we have a molecular compound which containing the hydrogen like this, we're going to hydrogen at the start or at the end. Basically, if we have like a acids, if you have a top cis acids or a weak acids from the table of in your data sheet, you can have to figure out how can you write this. That's all things are called the molecular compounds, which is starts with H or has the end with H, containing hydrogen basically. So what you do, you react the substance with water to form a hydronium ion. So you have to react with the substance to form the hydronium ion because this contains the H. We have to get rid of the H. Another product by determining the combination of the atom charges and required to balance the chemical equation. Other product is that things left in that because you have to balance the reactant and product side. That's why they are asking the other thing is the combination of the atoms or the charges which are required to balance the any chemical equation. Make sure you balance at the end. This reaction is already balanced. So HNO3, this is basically top cis and this is the strong acid. So it reacts with water and you will get H3O positive. You have to be like add this as a product. So what we left with? We left with NO3 and this has a charge of negative. So that's the reaction for the molecular compounds which is containing the hydrogen. So we prepare for this, that how can we write this thing, and this is balanced already. You have to check at the end which is balanced or not. Next thing we have an ionic compound, the compound which has the ionic properties. So ionic compound that does not contain the oxide or the hydroxide ions. This does not have oxide, it doesn't have the hydroxide ions. Like this has the hydroxide ion over there. And but this is ionic compound which not have any hydroxide ion on the outside. So what you have to do, first you have to write the deassociation reaction. This is the thing where we start thinking about like multiple reactions in the one question. And the second reaction reacts with the ion which produced by the first reaction, then with the water. Evidence provided if the final solution acid, write the hydrogen ion as a product. Final solution is a basic, then the hydroxide ion as the product. If we have acids as a final thing, so we have to write the hydrogen ion as a product. If the final product is basic, so we have to write the hydrogen ion as a product. So we're doing that, and I will tell you that how can we go to approach. So we have given like this Na3PO4 solid, which is basic. Then we have this is as an ionic compound. Then we start with this. We write this by water. So we have to firstly do a deassociation. So write like this because this is the basic. So when you deassociate, you get Na positive and you get PO4 3 negative. This should be aqueous. You know how this makes. So this has Na3 positive, you have a PO4 3 negative. So when interchange, you get Na3PO4 solid. This how can we make done. So we have to balance this. This should be 3. Then we balance this. Now you have to take the ionic thing from here, the ion thing with this, which is the negative thing. So you take this now. Take this in the nasty reaction as a product, and again you add this with the water. Now this is the weak base thing. So we have to use this. At the start we do the association. That's why we use the straight arrow. But now we use the equilibrium thing because this is the weak base. Now when we read this, now one thing more. So when we're doing from the basic, when we go from the basic to the things anything else, so we have to get rid of the H. We have to get rid of the H. Here we have the 3 negative. So we have to finish that 3 negative and put the, instead of 3 negative, we have to put the 3H, 3 hydrogens in the place of the over there. This is kind of in basic. In acid, we do the opposite thing. We also discuss that in the next few topics. We already discussed. We discussed that thing too. But in this, we have to get rid of this negative signs. 3 negative signs, which means we have to make the 3 reactions. The one by one, the H goes at different. First step, You get H first H at the front, HPO4. Now you get left with only two negative. And always you have to, because this is the basic, you have to be as I put it as the OH negative at the second thing. Now you take HPO4 to negative, aqueous plus water, weak base. Now you get the second H. Now you're left with only negative, one negative, and plus OH negative aqueous. Now take this thing, again react with water. Now you're left with a zero negative sign. So aqueous plus OH negative. As soon as your negative signs are finished in your, as soon as your minus sign is finished in your like basic thing, you will get your answer. At the end, you will have that thing. Then this is whole the answer. You have to write a four iterations. Firstly, deassociation. Then after this is the basis. We have to get rid of the negative signs and put the H of the inside one by one in the different three steps. This is weak base. That's why we write this. We put these equilibrium arrows. Next, we have a metallic oxide. Metallic oxide means we have a metal with the oxygen, which is the oxide. So, like we have this MgO solid. What we have to do, react a compound with the water to produce the ionic hydroxide. The ionic hydroxide means you have to make the ionic hydroxide at the end. Done with this. So first we have to react with this water. So MgO solid react with this water. You will get MgOH2. This is a simple reaction you get. Now, if when you get this, this is the first thing we do, the ionic hydroxide. So now we have to write this reaction, which is deassociation thing. So put this MgOH2 at the front and do the deassociation, which is Mg2 plus and 2OH negative. So I balance this over there. So that's the reaction for metallic oxide. Easy thing. Then we have a non-metallic oxide where we have like this SO3 gas. So we have to write this with water again. So we write with this water. So SO3 gas plus water in liquid, you will get H2SO4. Now H2SO4 is the acid thing. It's a weak acid, but this is acid. Now we have to do the reverse thing for the basic. In basic, if you have anything in basic, we have to get rid of the negative signs and get the hydrogen signs. In the acid, you have to get rid of the hydrogens and get the negative signs. So put H2SO4 at the front now. Aqueous plus water. Now this is a weak base, a weak acid, so you have to do this. So HSO4 negative aqueous. And in this, you have to get the hydronium ion because it's an acid. Then put this plus water, weak acid, you get SO4, 2 negative and aqueous. And the hydronium ions. You can see you have a 2H at the first, you get a 2 negative. You have to do 2 reactions to get rid of the hydrogen and get the negative sign one by one. This is 2 negative, you get the 2 reactions after that. So that's how it all works. The basic thing is the negative signs go and hydrogen signs comes. In this, we have to get rid of the hydrogen and get the negative sign. So that's all you have to do. And in the acid, the hydrogen ions produce, and in the basic, the hydroxide ions produce. Last thing we have the other, like you get something like a wave from the different from this all five. So if the substance does not fit into any of the above categories, react with the water to produce either the hydronium ion, hydroxide ion, or another product. So depending on the final solution as acid or basic. So this is nothing. So NH3 is the basic. So basically you get the OH negative ion at the end. So you can just react this with the water, and this is the weak base. So put like this. So you get NH4 positive aqueous plus hydronium ion. This is the thing where there's nothing fit with anything. So you write it like this. Only binary reaction and you get the hydroxide ion. So we have one example, the quick example, and we have discussed this and we're going to end. Okay, the example says the carbon dioxide is the major air pollutant from the combustion of the fossil fuels. Suggests the possible chemical reaction that explains the acidity of the carbon dioxide solution. So basically, we have a CO2 starting. So basically, CO2 is a non-metallic head outside. So first, we have to react with this water. We will get H2CO3 get aqueous. Now this is the weak acid. So you have to get rid of the hydrogen and get the negative sign. So this is simple thing we did already in the examples too with SO3. So you will get HCO3 negative plus the hydronium ion aqueous. Now this thing plus water and you get CO3 2 negative aqueous plus this. So that's how it works and you get the reaction. You have to just do with this. This is CO2. Did you get the answer? So that's all you have to do in the modified ARRHENIUS theory, and this is very important topic. And in the next topic, we'll start with the PHPOH, which is again very important topic of the chapter. And yeah, so that's all for this lesson. Let me show you why learn smart not harder. Please like, share, and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Till let's get it with EduVibe.